Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 10-7, Independent and Dependent Events. Two events are independent events if the occurrence of one event does not affect the occurrence of the other event. For example, rolling a 1 on a number cube and choosing an ace at random from a deck of cards are independent events. If two events, A and B, are independent events, then the fact that event B has occurred does not affect the probability of A. In other words, for independent events A and B, the probability of A equals the probability of A/B. You can use this as a criterion to determine whether two events are independent. Determining if events are independent. An airport employee collects data on 180 random flights that arrive at an airport. The data is shown in the two-way table. Is a late arrival independent of the flight being an international flight? Why or why not? So let event A be the event that the flight arrives late. Let B be the event that the flight is an international flight. Find the probability of A. First note that there is a total of how many flights? How many total flights? 180 total flights, right? Of these flights, there's a total of blank late flights, all right? Late arrival, there's 18 late arrivals. So the probability of A, that the flight arrives late, there are 18 late flights out of 180 flights total. So that's going to be what? 1 out of 10, which is 0.1 or 10%. Okay. To find the probability of A, then B, first note that there is a total of blank international flights. So there's a total of 60 international flights. Of these flights, there's a total of how many late flights? 6. So 6 out of 60 is 1/10 or 10%. Compare the probability of A and the probability of A, then B. So, a late arrival is independent of the flight being an international flight because the probability of A equals the probability of A, then B, which means that events A and B are independent events. In the example, you compare the probability of A and the probability of A, B. Suppose you compare the probability of B and the probability of BA. What do you find? What does this tell you? Okay, so the probability of B equals probability of B then A is going to be 33.3%. This also shows A and B are independent events. Okay, so let's see the probability of B. What was B? The flight is an international flight. So international flight, there's 60 international flights. And then A, the flight arrives late. So late, 6 out of 60. You can use a tree diagram to help you understand the formula for the probability of independent events. For example, consider tossing a coin 2 times. The outcome of one toss does not affect the outcome of the other toss, so the events are independent. The tree diagram shows that the probability of the coin landing heads up on both tosses is 1/4 because this is one of 4 equally likely outcomes at the end of toss 2. The probability is simply the product of the probabilities of the coins landing heads up on each individual toss. So each time you toss it, it's 1/2, right? One side is heads out of the 2 sides, right? Each time you toss it, there's 1 out of 2, 1 out of 2. All right, so A and B are independent events if and only if the probability of A and B equals the probability A times the probability of B. Okay, so that's your formula, the probability of independent events. So let's think about this, guys. Like if I toss the coin, it could either be the first toss, it could be heads or tails. The second toss, it could be heads or tails. So you could have heads, 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 tails, tails, heads, tails, tails. There's 4 different possible outcomes, right? And so for it to land land heads up on both tosses, that's 1 outcome out of the possible 4 outcomes, 1/4. So they were saying that heads is 1 side heads out of 2 sides. That's toss 1, toss 2. When you multiply them, you get 1/4, which is the same thing as here, 1 out of the 4 possible outcomes. Okay? Using the formula, you spin a spinner at the right 2 times. What is the probability that you spin an even number on the first spin followed by an odd number on the second spin? It's the probability of an even number. Okay, let A be the event that you spin an even number on the first spin. So an even number, let's see. 1, 2, 3. 3 even numbers out of how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. 3 out of 8. What about let B be the event that you spin an odd number on the second spin? So an odd number, 1, 2, 3, 4, 5, 5 out of 8. The outcome of the first spin does not affect the outcome of the second spin, so the events are independent events. The probability of A and B. The probability of A times the probability of B. So A times B, 5 times 3 is 15. 8 times 8 is 64. 15 over 64. The probability of spinning an even number on the first spin followed by an odd number on the second spin should happen approximately 15 out of 64 attempts. Yes. Yes. What is the probability that you will spin an odd number on the first spin followed by an even number on the second spin? What do you notice? Odd number on the first spin times even number on the second spin. You're still going to get 15 out of 64. You get the same answer. This is equal to the probability calculated above. These spins are independent of each other. So, the order of the outcomes doesn't change the overall probability. The formula for the probability of independent events gives you another way to determine whether 2 events are independent. That is, 2 events A and B are independent events if the probability of A and B equals the probability of A times the probability of B, showing that the events are independent. The 2A table shows the data from the first example. Show that the flight arriving on time and a flight being a domestic flight are independent events. Let A be the event that the flight arrives on time. Let B be the event that the flight is a domestic flight. Find the probability of A, probability of B, and the probability of A and B. Note that there is a total of blank flights. 180 flights, right? There is a total of blank on-time flights, 162. So the probability of A, the flight arrives on time, is 162 out of 180, which is 9 out of 10, or 90%, right? There is a total number of blank domestic flights, 120. So the probability of B is that the flight is a domestic flight. Well, there's 120 domestic flights out of 180 total flights. 120 out of 180 is going to reduce to 2/3. There is a total of blank on-time domestic flights, 108. The probability of A and B, you're going to have 108 out of 180 is 3/5. Compare A and B to PA times PB. All right, so PA times PB. Probability of A, 9/10, times probability of B, 2/3. You're going to have 18 over 30, which reduces to 9 over 15, which reduces to 3 over 5. 3 over 5. You could have reduced here. It would have been easier. 3 goes into 3 once. 3 goes in here 3 times. 2 goes in here once. 2 goes in here 5 times. And you'd have your 3/5. 3 times 1 is 3. 5 times 1 is 5. I like cross-reducing. So the events are independent events because P of A and B equals the probability of A times the probability of B. All right, so describe a different way you could show that the flight arriving on time and a flight being a domestic flight are independent events. So let events A and B be as in the example and show that the probability of A equals the probability of A slash B. Two events are independent events if the occurrence of one event affects the occurrence of the other event. To the bathroom. Suppose you have a bag containing 2 blue marbles, 2 black marbles. You choose a marble without looking, put it aside, and then choose a second marble. You put it aside. You guys see those key words? You put it aside. Consider the following events. Event A. The first marble you choose is blue. Event B, the second marble you choose is black. Events A and B are dependent events because you put it aside. You changed the data. Because the marble you choose from the first pick changes the sample space for your second pick. That is, the occurrence of event A affects the probability of event B. The probability that event B occurs given the event A has already occurred is called the conditional probability of B. Given A is written as the probability of B then A. The formula used to determine conditional probability is given by this. Multiplying both sides of P probability of A results in the probability of A times the probability of B then A, and which equals probability of A and B. This is known as multiplication rule. So you have your multiplication rule here. You can use the multiplication rule to find the probability of dependent or independent events. Note that when A and B are independent events, the probability of B then A equals the probability of B, and the rule may be written as the probability of A and B equals the probability of A times the probability of B, which is the rule of independent events. How can you write the multiplication rule in a different way by starting with the formula for the conditional probability and then multiplying both sides of that equation by the probability of B? So if you had this, that's the probability of A and B over the probability of B. You're going to multiply both sides by the probability of B, which results in the probability of A and B equals the probability of B times the probability of AB. Right? If you multiply by PB on both sides, you'd have this equals, this is just moved over here. There are 5 tiles with the letters A, B, C, D, and E in a bag. You choose a tile without looking. You put it aside. You put it aside. Independent or dependent? You put it aside. It's going to be dependent. And then choose another tile. The probability that you choose a constant followed by a vowel. All right, let A be the event that the first tile is constant. Let B be the event that the second tile is a vowel. Find the probability of A, and then the probability of B, then A. Okay, so the probability of A. Of the 5 tiles, 3 are constants, right? And A, we're doing the event that the first tile is a constant. So there's 3 constants out of how many tiles total? 3 out of 5, right? The probability of B. Of the 4 remaining tiles, 2 are vowels. B is a vowel. So 2 vowels out of 4 remaining tiles, which reduces to 1/2. Okay, so this is the probability of B after A already occurred, right? Because A affected B. Does that make sense? You already took out a tile, so something's missing. What's missing? You're missing one of those constants, right? Because the probability of a constant and then a vowel. So 1 constant's missing. So instead of there being 5 tiles total, there's only 4 to choose from. And there's 2 constants remaining. I'm sorry, 2 vowels remaining. Use the multiplication rule. The probability of A and B. The probability of A, 3/5, times the probability of 1/2. So you're going to have 3 times 1 is 3. 5 times 2 is 10. So it's going to be 3/10. Complete the tree diagram, then explain how you could use it to check your answer. All right, so the first tile, you could have A, B, C, D, or E. All right, then the second one, if you already chose A, then it could be B, C, D, or E. If you already chose B, then it could be A, C, D, E. If you chose C, it could be A, B, D, E. If you chose D, it could be A, B, C, E. If you chose E, it could be A, B, C, or D, right? For the second tile. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 possible outcomes. Right? You have 20 outcomes. And how many of these 20 outcomes have, what were we looking for again? Let A be the event that the first tile is a constant and B be a second tile is a vowel, right? Constant vowel. So which of these are constants? A, B, C, D, E. A is a vowel. Is B a constant? A, E, I, O, U, right? So these 3 are constants. So we have these 3, and then the second one has to be a vowel. So that's a vowel. Is that a vowel? No, no, yes. Yes, no, no, yes. Yes, no, no, yes. Yes, no, no, no. So how many are constant vowel? 1, 2, right? B-A, B-E. So 1, 2, 3, 4, 5, 6, 6. Right? Because that's not even fair game. So 6 outcomes are what we want out of 20 possible outcomes. 6 out of 20 reduces to 3 out of 10. You guys see how you got the 3 out of 10 here and the 3 out of 10 here? So doing the tree will also give you the correct answer. The tree diagram has 20 branches, and 6 of these circled correspond to the constants followed by a vowel. So the probability of a constant followed by a vowel is 6 out of 20, or 3/10. What does your answer tell you about the likelihood of choosing a constant followed by a vowel? The likelihood, it's the outcome's unlikely. It would theoretically occur 30% of the time. It's unlikely. Theoretically, only 30% of the time. Right? It's only going to occur about 30% of the time. A farmer wants to know if an insecticide is effective in preventing small insects called aphids from living on tomato plants. The farmer checks 80 plants. The data is shown in a two-way table. Is having aphids independent of being sprayed by the insecticide? Why or why not? All right, so is having aphids independent or dependent of being sprayed with the okay, so having aphids. There's 26 aphids out of 80. Right? 26 out of 80, which is 32.5%. Oh, you can't see what I'm writing. Okay. So the probability of aphids, the insecticide, was sprayed with insecticide. So 12 of them have aphids that were sprayed with the insecticide out of the 52 sprayed with insecticide. 12 out of 52 reduces to, it's going to be about 23%, right? If I divide that and move my decimal 2 places, I get the 23%. Since these probabilities are not equal, the events are not independent. Because 32.5% of all the plants have aphids, but only 23% of the ones that were sprayed with the insecticide. So you have to assume that the insecticide's doing a little bit of something. Not a ton, but a little bit, right? This is the 32.5% of plants, of all plants, have aphids. But the ones sprayed with insecticide, only 23%. So like that's like what? 77% of the ones that were treated don't have it. So it seems like it's doing a decent job, right? If about approximately 3/4 of the ones sprayed are okay. It must be doing something. You spin a spinner with 8 equal sections numbered 1 through 8, and you roll a number cube with sides numbered 1 through 6. Find the probability of each of the following. Write the probabilities as fractions. The spinner lands on a 1, and you roll a 5. You spin a spinner with 8 equal sections, 1 through 8, and you roll a number cube with sides 1 through 6. Okay, so 1 through 8 and 1 through 6. The spinner lands on 1. That's one part out of 8 equal sections. And you roll a 5. That's 1 out of 6 equal things. So 1/8 times 1/6 is 1 out of 48. The spinner lands on an even number. All right, so the spinner, there's 8 equal sections, 1 through 8. So even numbers, 2, 4, 6, and 8. That's 4 out of 8. And you roll an even number. So that'd be 2, 4, and 6. That's 3 out of 6. 4 out of 8 reduces to 1/2. 3 out of 6 reduces to 1/2, and 1/2 times 1/2 is 1/4. The spinner lands on a prime number. All right, so prime numbers from 1 to 8. 1 is not prime. 2 is prime. 3 is prime. 4 is not. 5 is prime. 6 is not. 7 is prime. So that's 4 of them out of 8, right, are prime. Prime numbers are divisible by 1 in themselves. 1 is not prime. And you roll a number greater than 4, so 5 or 6. So that's 2 out of 6. 4 out of 8 is 1/2. 2 out of 6 is 1/3. 1/2 times 1/3 is 1/6. The sum of the number on which the spinner lands, and the number you roll is 14. Oh, Jesus, this is going to be annoying. Sorry. All right. The sum of the number of the spinner lands. Okay, so your spinner can land on 1, 2, 3, 4, 5, 6, 7, or 8, right? And then the number you roll. You could roll 1, 2, 3, 4, 5, or 6 on all of these. All right, so what's going to add to 14? Would 1 plus 6 add to 14? No, none of those are going to work. Is 2 plus 6 is going to give you 8? Never going to work, any of those. 3 plus 6 is 9, never going to work. 4 plus 6 is 10, never going to work. 5 plus 6 is 11, no. 6 plus 6 is 12, no. 7 plus 6, 13, no. 8 plus 6. 8 plus 6 is 14. So that's the only way that you're going to get 14, right? And there's going to be 6 times 8. 6 times 8 is 48 different possibilities. 48 different things and only one works. 1 out of 48. I didn't draw it all out because that would just be a total nightmare. Right? I just started the tree and I was like, okay, what would be 1 through 6? Well, 6 plus 1 is 7, not big enough. 7 plus 6, right? This number plus the highest possible dice, it didn't get to where it was a possibility until here. So there's 6 things, there's 6 branches off of each of these. So 6 times 8 is 48 different possibilities, and only one of them is going to add to 14. Make sense? A student wants to know if right-handed people are more or less likely to play a musical instrument than left-handed people. The student collects data from 250 people, as shown in a two-way table. Show that being right-handed and playing a musical instrument are independent events. All right, so being right-handed and playing a musical instrument. So the probability of right-handed, there are 220 right-handed people out of 250 total people, right? So it's 22 out of 25 people are right-handed. So the probability of playing a musical instrument. So the probability of plays a musical instrument. 50 people play a musical instrument out of 250 total people. That's going to be 1/5. How about the probability of right-handed and plays? That's going to be right-handed plays 44 out of 250, which is 22 out of 125. All right, so since the probability of right times the probability of plays equals the probability of right and plays, the events are independent. Right times plays equals this, right? And they're independent. A basket contains 6 bottles of apple juice and 8 bottles of grape juice. You choose a bottle without looking. You put it aside. Independent or dependent? Dependent. And then choose another bottle. What is the probability that you choose a bottle of apple juice followed by a bottle of grape juice? So apple juice. 6 bottles are apple juice out of how many total bottles? 6 out of 14, right? 6 plus 8 is 14. And then you choose another bottle. So now grape juice. There's 8 bottles of grape juice out of how many remaining bottles? 13. And if I multiply this, let's reduce this first. This would be 3 and 7. 3 times 8, 24. 7 times 13, 91. So 24 out of 91. You have a set of 10 cards that are numbered 1 to 10. You shuffle the cards and choose a card at random. You put the card aside, dependent, and choose, dependent, right? And choose another card. What is the probability that you choose an even number followed by an odd number? So 1 through 10. How many evens are 1 through 10? 2, 4, 6, 8, and 10. 5 out of 10. And then you choose an odd number. Well, how many are odds? 1, 3, 5, 7, and 9. There's 5 odds out of only 9 remaining cards. So it's 25 out of 90. Or you could have reduced this to 5 out of 18. A bag contains, what if I would have done the probability of selecting a even followed by an even? What if I wanted even, then even without replacement? Right, I put it aside. Well, even, 5 out of 10. Well, now there's only 4 out of 9. So that'd be 1/2 times 4/9 is 4 out of 18. Does that make sense? You guys see how that would work? But there's 1 less even and there's 1 less card. A bag contains 3 red marbles and 5 green marbles. You choose a marble without looking, put it aside, and then choose another marble. What is the probability that you choose 2 reds? Well, there's 3 reds out of 8 total marbles. Now there's only 2 reds left to choose out of 7 marbles to choose from. So 3 times 2 is 6. Oh, I can reduce this. So that's going to be 3 over 28. Is the probability different if you replace the first marble before choosing the second marble? Yes. With replacement, you add 3 out of 8, and then you're going to still have 3 out of 8. So then that would have been 9 out of 64. 9 out of 64 is different than 3 out of 28, right? 9 out of 64 is a different number than 3 out of 28. If I took my 9 divided by 64, this is approximately 0.14 or 14%, where 3 divided by 28 is 10.7%. They're different percentages, okay? There are 12 boys and 14 girls in Miss Garcia's class. She chooses a student at random to solve a geometry problem on the board. She then chooses another student at random to check the first student's work. Is she more likely to choose a boy followed by a girl followed by a boy, or are these both equally likely? Explain. Well, if she was going to do a boy followed by a girl, how many boys? 12 boys out of 26, followed by a girl, 14 girls out of the 25 remaining students. If we were going to do it the other way, a girl followed by a boy, a girl followed by a boy, you're going to have a 12 and a 14, you're going to have a 26 and a 25. Isn't it going to be the same thing? Right? They are both equally likely. Both of them are going to give you 84 over 325. All right, so you roll a blue number cube and a red number cube at the same time. You are interested in the probability that you roll a 2 on the blue number cube and the sum of the numbers shown on the cubes is 7. All right, so you have a blue cube and a red cube. So 1, 2, 3, 4, 5, 6, right? You want a 2 on the blue cube. And the sum of the number shown on the cubes is 7. Well, 2 plus what is 7? 2 plus 5. That's one thing that you want out of 6 times 6 is 36 different possible answers. So that's 1 out of 36. This is going to be dependent. Rolling a 2 on the blue cube affects the probability that the sum of the numbers rolled is 7. Because you could have gotten 7 other ways, but this is contingent on the fact that it has to be a 2 first, right? So it changes the odds. What is the probability? 1 out of 36. There are other ways to roll a 7. It could have been a 5 and a 2. 5 on blue and 2 on red. But we can't include that because of the fact that they want the blue to be a 2. And if the blue is a 2, then the red has to be a 5. Okay, we'll do one more and then we'll leave it at that. All right, so let's do these. Tell if they're independent or dependent. You roll a number cube and then flip a coin. The number cube shows a 3. The coin shows tails. Are these going to be independent or dependent of each other? A number cube and a coin. They're independent. The number cube shows a 3. That's one side out of 6 sides. And the coin shows tails. That's 1 out of 2. So my answer is going to be 1 out of 12. You write each of the letters in commute on a separate slip of paper and put them in a hat. You randomly draw one letter. Do not replace it in the hat and then draw a second letter. Independent or dependent? Dependent. All right, so the first letter is M. How many M's? 2 out of the total number of letters. 1, 2, 3, 4, 5, 6, 7. 2 out of 7. Now there's only 6 letters left. The second one's an E. 1 out of 6. 2 times 1 is 2. 7 times 6? 42. 2 out of 42 is 1 out of 21. You roll 2 number cubes. You roll a 4 first and you roll a 3 second. Independent or dependent? Independent, right? You roll a 4. That's 1 out of how many sides? There's 1 4 out of how many sides? 6 sides. You roll a 3 second. That's 1 out of 6 sides. 1 out of 36. Are we okay? All right, guys. Your homework tonight is page 603 and 604 in your workbook. I hope you enjoyed today's lesson. Please like and subscribe and have a fantastic day.